Hi, welcome to demo of my VCC assignment 3. So what I'm trying to create here is a mock job scheduler. So this job scheduler basically schedules job on some nodes. So my primary executor node is my local VM, which is going to be VM1. So this VM is on my local machine on my laptop, and this VM is my primary executor. So when I get a job, I'll assign that job to this VM first. Uh, when the when this VM is overutilized, when the CPU usage is high for this VM, higher than a defined threshold, then what I'm going to do is I'm going to spin up a new VM in cloud. How this VM gets spinned up in cloud? I have a scaling logic over here. I have a stack of services deployed. So I have a Prometheus service. I have already have a node executor installed on VM1, which exports CPU utilization, memory, etc. metrics, and these metrics are scraped by Prometheus. So Prometheus will scrape those metrics, and it has a logic to generate alerts from those metrics. So when the CPU utilization is high for VM1, Prometheus will generate an alert and inform Alert Manager. Alert Manager is another utility which is often used along with Prometheus, and Alert Manager is the service which is integrated to receive alerts from Prometheus when Prometheus runs into any. So alert manager is then supposed to pass it over to other alerting tools which broadcast it over certain channels for uh, people to look into the issue, and sometimes it is also integrated with other softwares to take corrective actions. Here we have integrated alert manager with our Flash service. Uh, when alert manager gets an alert that VM1 has very high CPU utilization, then uh, we this alert is passed over to the Flash service, and Flash service creates a VM in GCP. When Flash service creates a VM in GCP, the scaling of VM in GCP is taken care of by the GCP autoscaler. GCP autoscaler will look at CPU utilization of VM1, and if the CPU utilization of VM1 is high, GCP autoscaler will autoscale, and it will scale up the VMs in cloud. And for the current demo, the maximum capability is going to be 5. So GCP can scale up to 5. VMs in GCP can scale up to VM1 to VM5. When again my VM1 is below the threshold, like if the VM1 is again underutilized, my Flash service will receive a alert resolution message from Alert Manager. And when alert Flash service receives that alert, Flash service is going to remove the VMs from cloud, and then I will only have one VM, which is going to be my local VM. So now let's jump into the details. I have a Vagrant file. So this Vagrant file has the definition of my local VM, VM1. So for my VM1, I have a static IP that I am using. I am using this IP for scripting Prometheus metrics. We'll look at it later. This has 1 GB RAM, 1 CPU, and it has stress ng. This is for mocking CPU utilization, and it has node exporter. So here is code to download and install node exporter and run node exporter in my VM1, which is going to be my local VM. So here is my Oracle VirtualBox, and here is my VM1 running. So I have already run vagrant up command, and my VM1 is up and running. So that is my vagrant VM1. Now let's look at my stack of Prometheus, Alert Manager, and Flash service. So here is my Docker Compose file for those services. I have Prometheus. I am using Prometheus image. Here you can see Prometheus latest, and I have given it a prometheus.yaml and alerts.yaml file. These have configuration of from where to scrape the metrics, and the alert configuration. These details, these two YAML files are. We'll look at those. We'll look at those. This is the port that I'm exposing, 9090. We'll look at that again. We'll look at it later. I'm using monitoring network. I'm using same network for all of the services. Then I have alert manager. I'm passing it a alert manager.yaml as a config file. This is exposed over port 9093. Again, we'll look at this later. And I have a Flash service. This flash service is exposed over 5,000. I am passing my credentials.json to this flash service, and I'm passing it here so that I can execute GLP command from my flash service. And again, this is also we have one monitoring network on which all my VMs sit. So that is the stack of these services. Now let's look at the configs and the logic. So my Prometheus.yaml has a configuration where I have defined it to scrape the metrics for my static IP that we have seen in background file. So my VM1 has this IP address, and 9100 is the port over which the metrics are exposed by the node exporter. So Prometheus is supposed to scrape metrics from this endpoint, and there is another alerts.yaml that we'll be going to look at. These are my these are the rules for alert, and also I have given it a configuration to locate the alert manager. So my Prometheus now knows that my alert manager is uh, alert manager service listening at port 9093. Now look at the alerts. So these are the alerts definition that has been passed to Prometheus. So what it will do is it will look at the total CPU seconds. It is going to irate it over 10 seconds idle tag for idle tag. So basically it's like idle time. It is going to check the rate of idle time over the last 10 seconds, and then it is going to subtract it by 1 and then multiply by 100 to make it in percentage, and it is going to check if it is greater than 75 or not. So 75 is my threshold, and it is going to check if it is true for 10 seconds. So if this is true for 10 seconds, then what Prometheus will do is it will create a severity alert, and it will have this as summary and description in that alert. This alert will be then sent over to alert manager. So alert manager, what it will do is it will take in the alert. So this is the configuration that is going to be passed to alert manager. So alert manager will get the request. So I have a different kind of setting which is not usually recommended. So this I have done so that I am able to quickly move the alerts from Prometheus to Flash service. Ideally, we would want some thought over values for these configurations, but for my demo I have made it as low as possible and repeat interval as high as possible. And then what I'm doing is I'm going to forward all of these to my flash service, and I'm going to send it over 5000 slash scale endpoint. So 5000 is my port at which my flash service is listening, and slash scale is the endpoint that we are going to look at now. So this is my Flash service. So this Flash service has two endpoints. There is one endpoint called submit job. So this will allow users to submit job. This we are going to look at it later. And then we have this scale endpoint that we have just seen. So when alerts will come to this scale endpoint, and based on the alert, what I'm going to do is I am going to change the auto scaler configuration. So when I need to scale up, I'll say my auto scaler to have minimum value as 1 and maximum value of 5 as the number of VMs in my instance group. And when I have to scale down, I'll say my auto scaler to have minimum 0 and maximum 0 VMs in my instance group, because when I need to scale down, I don't need VM in my cloud VM, in my cloud instance group, GCP. So this is that. Now, the working principle is that user will submit a job. So let me show you the first endpoint as well. So when a user submits a job, user can submit three kinds of jobs. So I have three jobs: small, medium, and large. Small jobs are small jobs which will execute least amount of load on my executor. Medium are one which will execute some load for some duration, and large is one which will execute a CPU utilization of 80% over 4 minutes. So medium will execute 80% CPU utilization over 60 minutes. Large will execute 80% CPU utilization over 240 minutes, and small will execute 40 CPU utilization over 5 minutes. And this what I'm doing is I'm executing SSH command to that particular VM. I have a logic to get all the GCP instances, and I'm including my VM, local VM, and then I'm going to find the available VM, the VM with least amount of with least load, and I'm going to forward my request to that VM. And when I forward the request to that VM, I'm going to execute trigger stress on that particular VM. So I'm executing stress using SSH commands. So this is my command to execute stress on my Vagrant VM, and this is my command to execute stress on my GCP VM. And yeah, that's it. And I'll execute stress, and then my scaling logic will take care of scaling it. So that being said, now we can execute and we can check. Let me check if there is something else that we need to go through. Okay, so let me also take you through my Terraform code. So I have this main.tf over here. So this main.tf, what it will do is it will again it will use GCP. This is basically a GCP code. GCP, it will use a GCP provider, and it will create a instance template. So this is my instance template. I need it because I want to install stress ng in all the VMs so that I can execute, I can mock that stress CPU utilization part. And this is the disk network interface. So require network so that I can enable SSH, so that I am able to send SSH commands from my application. I have an instance group manager called Cloud VM Group. This instance group will be the group where I will be setting the autoscaler logic to increment or decrement the number of VMs. This is my autoscaler. So by default, it is 0 to 5. Uh, Depending upon my scaling requirements, I will make it 1 to 5 or 0 to 0. That is taken care of by my Flask application. And then I have a firewall rule to enable SSH so that my Flask application can trigger SSH commands on that. So that this is my Terraform code. And then I have a Docker file for my Flask application. So this Docker file allows me to install Python 3 pip, SSH pass. This is so that I'm able to execute SSH commands on my on my local VM. Yeah, so that is it pretty much. So I have shown that the local VM1 is already up and running. So what I need to do is I need to up my Docker Compose. Yeah, so I need to bring up my Docker Compose, and I need to apply my Terraform logic. So I'll say Terraform plan out new. So this will create my Terraform plan. And here my services have started. I'll just tail my Flask service so that we can see the logs there. So Docker logs -f Flask service. So this is tailing my Flask service. And this is, I have my Terraform planning done. I need to apply. So to apply, I'll say Terraform apply new. Okay. So this will go ahead and this will create my resources in in GCP. So we'll wait for it. Meanwhile, let's look at this. Let's look at my scaling stack. So my let me go to my local host 9030. Let me check my Docker file. So Prometheus is at 9090. So this is my Prometheus. I'll show the alerts. This is my alert, which is configured that we have seen in alert.yaml file, alerts.yaml. I'll use this formula and we'll check the graph for CPU utilization over time. So this is my CPU utilization. Let's make it for last 15 minutes. So this is my CPU utilization over last 15 minutes. When I get an alert, this alert will go into pending state first because it is going to wait for 10 seconds. If the alert does not suppress within 10 seconds, it will go to firing state, and the alert will move from Prometheus to alert manager. So let's look at alert manager as well. So my alert manager is running at 9093, localhost 9093. This is my alert manager. So there are no alerts right now. So we are not able to see anything over here. If you go into okay, I don't think we'll be able to see. Okay, here is the configuration, and one can see that the requests are going to get forwarded to the Flask service. So this is my alert manager. So this is my alert manager, and also let me show you this my uh, VM. So I'll go to Prometheus .yaml. Where it is? Prometheus.yaml. So yeah, 9100. This is the static IP. So let's look at this slash matrix. It's getting a little uh, like, since the CPU and memory utilization on my laptop is very high, it's taking a little time. So this is the slash matrix endpoint, and all the metrics are exported here, and these metrics are scraped by Prometheus. One can see there are different metrics over here. So right now what we are showing is uh, node CPU seconds total. One can see that over here. It's lagging too much. Yeah, here one can see there is node CPU seconds total. This is what we are tracking there, and we are tracking for mode idle. So this is our mode idle, and with this we are able to conclude what is the CPU load. If this decreases too much, then it means my CPU is very much overloaded, and that is how this alert will work and send the alert out. So now we have seen all this. What I'm going to do is I'm going to start up. I'm going to send jobs now. So what I'm going to do is I'm going to send a job. So this is my Flask service endpoint 5000. I'm going to submit a job. I'm going to submit a small job first. Let's send a small job. So when I send a small job, it's a load of 40 seconds for 5. So this is always going to go first to my VirtualBox VM, and the status is success. So my job should have come. And let's look at the CPU utilization. It should be uh, around 40. Execute. And let's look at the graph, and let's look for last 5 minutes. So here is that brief 5-second duration when my CPU utilization is 40. So this is the duration. So it is about 5 seconds, 4 seconds, 4 seconds, something like that. So that's the window here. So yeah, so that's my small job. Let me execute. Click on this again. Yeah, it's still at 40, it seems. Oh, I need to close this. Sorry. And execute, and let's make it 5 minutes. Yeah. So this is my duration when I was executing a small job. Now what we'll do is we'll go ahead and we'll create a medium job. So I'll say a medium job type. When I say send a medium job type, it is going to create a load of yeah, it is going to create a load of 80 for 1 minute. So when a load of 80 is seen, we'll see the alerts getting triggered and the auto scaling getting triggered. So let's do it. So I'll be sending a medium job type. I'll click on send. So the job has been sent to VirtualBox VM. It is success. Load is of 80 and duration is 1 minute. Now let's look at this Prometheus. So one can see that it is climbing to 80. This is around 80%. One can see this is like going to, it is reaching 80%. Now what we'll do is we'll go ahead and we'll look at alerts. So this alert has already been fired. So I could not show the yellow part when it was in pending state, but it has been fired now, and the alert would be visible in alert manager as well. So the alert has come, it has been forwarded to Flash service. Let's look at our Flash service logs. So the Flash service says it has run into high CPU utilization and it has fired scaling. So now scaling has been triggered, and in my GCP, we should be able to see a new VM coming up. So this is my instance group. I'll reload the page, and the status was changed. So this is the VM is running. So my VM has come up in my VM group. So this is a new VM. One can see the creation time is just 1 minute, some few seconds before. So this is 11:21, and right now the time is 11:22. So this is the VM that has scaled up. Now let's wait for it to get resolved. Okay, so it has got auto resolved because it was only for 60 seconds. So now the alert is resolved. So instance group resized to 0 instances. This has been logged. So it means my Flask application has asked my cloud to reduce the instances. Let's go back here. So you can see auto scaling, it is 0 by 0 now, 0 minimum, 0 maximum. And my VM state is VM is being deleted. So this the status is VM is being deleted and this VM is going down. This is the scale down part of it. So once this is down, so my auto scaling, this VM will get down from here. Yeah, now the VM is deleted. Now we don't have any VM, and that is because my VM1 is now free to execute more jobs. Now let's go one step further and let's execute the high job. Okay, it says invalid job type. Let me check the job type. Okay, it's large. My bad. So let's execute large job. So the execute large job has been successful. It's going to be there for 240 seconds. And let's see here. Let's see in our Prometheus if we are getting that alert yet or not. Okay, we are into that alert. Okay, so this is now in pending state. So that alert has come up, but it has not been there for 10 seconds yet. So it is in pending state. Once it is there for 10 seconds, it will go to firing state. We need to keep reloading the page. It is in firing state now. The alert manager should have got this alert now. So this is the new alert. If we can look at the timestamp to understand that. And the alert has come to Flash service, and Flash service has triggered scaling. So my GCP will get the VMs. Let me reload this. And meanwhile, let's check the user as well. Okay, so GCP, the VM, I think it is coming up. So the status is VM is being created. So we'll wait for a few seconds for it to get green. And meanwhile, let's look at the graph. Uh, Let me copy it and let's search for this. So this is my graph. Let's look for last 5 minutes. Or let's look for last 15 minutes. So it is up since some time. Let's look for last 5 minutes. Yeah. So this is constantly at 80% CPU utilization. Uh, okay, this is green now. Now what we'll do is we'll go ahead and we'll send a job, another medium job maybe. So this was executed on VirtualBox VM. Let's execute a medium job. So this job was executed on VM KPKH. This is my KPKH VM on which that medium job was executed. Let's go back to the instance group. So we are in monitoring and we can see the mean CPU utilization is 53.26. So this has come up because I have added a medium job. So the CPU utilization earlier was low and it is now climbing to at tops 80%. Here it has climbed up to 82.95. So when I got when a medium job was was encountered. Since my virtual box VM was already executing a high job, my VM medium job was sent over to GCP, and it was executed in uh, this VM. So yeah, that's it. And here I think my auto scaling is for the auto scaling might not be recognizing it now, because before the auto scaling scales up the VM, I think the load will start coming down. So maybe if we can change that auto scaling also to see auto scaling happening in VM group as well, in this group, I mean. So we'll have more number of VMs if this VM keeps overloaded for more than some threshold, CPU threshold, for more duration of time. So that is it. I'm going to stop the recording, and I'm going to upload the document and other things in the GitHub repo, and it will be shared. So that's it. Thank you.